and then just the regular chi-test.
Okay.
What I'm going through right now.
All right. With many babies being delivered by planned, okay, section statistics classifies that there would be fewer young people born on the weekend. To investigate, they selected a random sample of people born before 1980 and a separate random sample of people born after 1993. In addition to the year of birth, they also recorded the day of the week on which each person was born. Okay. So they're trying to determine if there's a relationship between the day of week and deliveries by C-section.
Right, right.
And they hypothesized that there were fewer people born on the weekend, although I guess they don't care about how the birth occurred.
Right.
So they're just looking at whether day of week and babies are, whether there's a relationship. So it'd be all the days of the week and then babies. And to me, what they're looking for is like, is there, like they believe that these are uniformly distributed is the way I'm.
Okay.
And I guess they're doing this with the year of birth as well. But they're just looking at this. This is written so weird because what I don't know is whether they're also like comparing like pre 1980
Right.
and then
Right.
post 1993, and then you could compare day of week and year. Maybe I'll defer here to what the solutions say, but this is what they're trying to compare between.
Right. And so trying to like determine which chi-square test would be best to solve that, or to plug in, right?
Well, it depends on, like I said, like, because you can use a chi-square test to determine if a single row here is uniformly distributed.
Right.
That would be a use of a chi-square test. I don't know if you guys are covering that in your class. I don't think so. So my guess is it's something to do with this year. Is year or period independent from day of week?
Okay. From what I picked up from the book, it says the chi-square test for homogeneity. How do you say that? Homogeneity?
Homogeneity, yeah.
Homogeneity. The data came from 2 independent random samples. So I think they're just trying to like determine which chi-square test is best for that.
Yeah. So here's the language I really like here. Quick Google search. I think it's what you just said, but this will be more meaningful to you. Test whether, and don't worry about the rows or columns, but basically whether the come from the same population or not. Are pre-1980 the same population as post-1993, or whether there's differences.
Right.
And that's what this is going for here.
Because let me see, where was it? Yeah, because the homogeneity is like one categorical variable in like 2 different populations. So
yes.
1993 and then 1980. The category was like which days they were born. Okay.
All right.
And then
so for the next one, is there more than just because does it end with whether or not they are vegan, vegetarian?
Oh,
is there anything cut off?
The second question?
Yeah, are younger people more likely to be vegan, vegetarian? They ask them for their age and whether they are not vegan, vegetarian. So this is one population, I guess, by comparison, because they ask US adults, and then they're probably grouping them by age. And then there's just a vegan, veg, and then age group here. Like I'll just say like 0 to 17 and 18 to 36, something like that. But just one population. What were the you said independence? I don't remember what the other one was.
Oh, it was just the regular chi-square test and then the homogeneity. Like 3 different ones.
This is independence, because you're trying to determine whether the 2 variables are related or not, age and vegan, veg.
Yeah. So it's just okay. So it would be for independence.
Yes.
Okay. Perfect.
All right. What's next? You're 49.
Yeah, 49.
All right, here is the full. That goes onto another page. I appreciate you cropping these. You can always just send them all over full pictures, and I can crop them during the
Oh,
lesson.
okay.
You don't have to spend a lot of time
Gotcha.
editing.
Yeah, no, I just take like quick snippets and just like, crop it to like what's the, the important stuff. And then the second picture that I sent is like all the information
Yeah.
that comes with it.
Yes. So here we go. Just so there's like this nice framing of it. Here's the next part. All right. Where do you live now? So gender, and then parents' home, another person's home, own place, group quarters, total, like that. Should we use a chi-square test for homogeneity or chi-square test for independence in this setting? Justify your answer. So because it's a sample of young adults, that's one population.
Right.
So one population is generally not for homogeneity. Usually it's for independence. Like, is gender and living location independent is what you typically are looking at here.
I see. So it kind of gives it away that it's just one population.
A little bit, yeah. Like that, and that, think about back to that, like what would it take for this to be homogeneity? It'd be like males from, I don't know, Tennessee and females from Arizona, something like that. Could be, there'd have to be some separation of the populations. All right.
Okay, I see.
And then part B says to state the appropriate hypothesis. That's your living location and gender are independent. Nope, they are dependent as the null and alternatives.
Right. Oh, dependent of each other. And then A, independent of each other. Okay.
All right, so let me just reset here the screen for the next two parts here. Part C, check that the conditions for carrying out the test are met. The one main one we talked about last time is that the expected counts have to be greater than 5. And
Right.
it appears that in this mini tab output, I think the expected counts are in the second row of each cell.
Right.
And they all are bigger than 5.
Yeah, no, they're very bigger
Okay.
than 5. So it's all
and I think there was some other ones like I don't know, independence, randomness, something like that. You can look those
right.
up in the book. Interpret the p-value. That's the big one. Like there's a lot of like other stuff here, but the p-value is really all you care about. 0.012, is that less than alpha?
1.2, is that less than alpha? Because we're only using the 0.05 alpha. Yes, it is left. So
It is.
we are able to reject
reject H0, and you conclude the null hypothesis, or I'm sorry, the alternative. You conclude the alternative hypothesis. There's evidence to support it. Whatever,
right.
whatever, generally that's what you say. It's specific to the scenario.
Perfect. Okay. Yeah, done and done. Okay. So then
you may want to look for the conditions of carrying out the test. Just have that, available to you if you need.
Right. Yeah, no,
there's conditions for all the tests, Z, T, chi-square, F, all the different ones.
There's like 5 different ones now, isn't there? Or wait, no, that's for the never mind. That's for the next chapter. There's like what is it called? It's called inference for slope.
Yeah, there's another.
Get back into the regression line.
At 51, it says, where do you live? Conduct a follow-up analysis for the test in exercise 49. I don't know what that means. I guess that maybe that's asking you to think about your situation.
Right. Let me take a look. I can take a look in the book real quick.
Yeah. I mean, I assume you're living at home with your parents. You're probably not in a group.
I see. So it's kind of just like explaining what the yeah, pretty much explaining like what you got out of it, like adding the chi-square and like there were more males living in their parents' home than would have been expected. And the Lexnar just there were fewer females living in their parents' home than there would have been expected.
So that's looking at the table of the expected counts. That shows, for example, you can see you have your book in front of you, or do you want me to snip that in?
Oh, I got the book right here.
Okay, so like it's saying that there were 923 females living at home, but the expected count was 978.
978. Oh, I see.
And there were 986 males living at home. The expected was 930.
Got
They're
you.
saying
Okay,
things like that.
so they're pretty much just saying like answer that, like what, conduct a follow-up analysis. Okay.
So, yeah, and now that we know what that means, you could do it for all of them. I was going to just make a side comment that you see these articles written from time to time. It'll say things like, parents, your kids ages 25 are still living at home at a higher percentage compared to, 25-year-olds from 10 years ago. You do,
Right. You
but
do see
that's not what
those
they're looking
sometimes.
for. They're looking for how does the expected counts compare to the actual counts?
I see. Okay. Huh. Yeah, because it looks like they were just like minusing the expected counts from the.
Like the group ones are really close, 127 and 126, 119 for males, 119.91 for males. Those are really close.
Okay. Huh. Interesting. Okay, we can move on.
Okay, what's next?
It was the
55.
yeah, I think that's it. Pretty sure. Hold on, let me. Yeah. Wait, was it 55?
I'm not sure.
53. Well, let me take a look. Hold on. I sent the pictures real quick. Let me see. So you got 47, 49, 51. And then yeah, so it's a bunch of like multiple choice questions pretty much.
Yeah, so here's the 55 is what I see. That's okay.
Right. Yeah, that's all good.
So sometimes it's better to go and look through this list and decide which ones maybe are wrong, or a couple ways to do like, oh, this one's wrong, or this one's for sure right. There's some keywords I guess I'll highlight, like equal proportions. And so the second one is sample population. That's kind of important to look at. Sample population. That's to help if
which one's null hypothesis performing a chi-square test. Okay.
So like my question for you on A is, have you seen a chi-square test with proportions?
No, I don't think so.
They're always frequency counts.
Right.
Goodbye.
So we can cross A out.
The next, B and C, D and E, so having taught some test prep classes, like I know that when they write these, like there's one word that's different here. You got to decide whether is the null hypothesis on the sample or the population, because that will then eliminate two of the answers.
The sample or population would be in the sample, right?
So think back to like the earliest types of null and alternative testing. Does this symbol represent the sample or the population?
The sample.
This is the population. Greek letters are always, Greek.
Oh,
yeah. So it's never on the sample.
It's never on the sample, so it's always about the population.
Always.
Okay. So then that just leaves.
So these are both true. I think we've even used this type of language. There's no difference. There is no association.
Population. So is it either or? Is there like a little bit?
I read it as it could be both.
It could be both.
It's C and E is the way I read it.
I see. Okay. So which of the following? Interesting. The book said E, which was interesting. I wonder
So
why.
so it does not like the no difference between the distributions. Okay.
Yeah.
So it doesn't like the fact that we're using distributions here. Okay, well, all right.
Interesting.
I don't know. You can use a chi-square test to test a distribution. You're supposed to though specify the distribution. You're supposed to say like this data follow a normal distribution. Here,
I'm sorry. I don't mean to interrupt. I just realized something.
yes, what is that?
There was the multiple choice questions. They're responding to a another question right here that's already being asked. I didn't see that part. I'm
All right.
sorry.
Well,
Yeah,
that could be why the
I'm sorry. That was totally my bad.
that's okay. That's okay.
There we go. Okay. I sent
What's
it there. I was gonna say like something seemed off. It was like all the questions were like associated in a way, and it was just like right in the bottom corner.
yeah, like for 57, I can tell now that it's referring to something because it says these data and it's referring back to something else in there. Okay. Yeah, so that takes care of that. Are we going on to 56, 57?
Yeah, 56.
56. Okay. So the expected counts of females who respond almost certain. So I'm looking at your picture here. Female total is 2625. Almost certain row total is 1930. So you multiply those together
1930.
and you divide by the super total or the grand total, 4,877. Do you have an answer for me that you like?
Sorry. Yeah, I'll just plugging it in real quick. Let me see. Oh, hold on. I think I might accidentally did something wrong. So it's 2625, 11930. Oh no, I'm jacking it up. Okay, I got 1038.
Good. Good.
Yeah.
All right, let's see what's next here. 57.
Yeah.
All right, so degrees of freedom. You take the number of rows, subtract 1. Don't include the totals. Number of columns, subtract 1. So what I'm looking at here is there are, sorry, I lost here. 1, 2, 3, 4, 5 rows.
5 rows. Yeah.
2 columns, so it's 5 minus 1 times 2 minus 1, which is
4.
4.
So
Not sure where that comes from. Feels like magic a little bit, but
yeah,
it's
very interesting.
Does what it is. See, let's see here. We got time for any more here. Do you have 58? Do we need to do 58?
Yeah, 58.
Okay.
One more.
Okay, good. Can do that for sure. For these data, chi-squared is 69.8. You actually don't care about the chi-squared. Again, the p-value is really, p-value is 0. So the p-value, which is 0, is less than every alpha imaginable. So we reject H0, okay? A type 1 error is possible when you reject H0.
H0. Okay.
A type 2 error is possible when you fail to reject H0.
Right.
Okay, so you have to remember that. It's like your note card, your Quizlet, and things like that.
Okay.
There is never no chance of making a type 1 or type 2 error. That these are garbage. You can't, there's always a probability of type 1 or type 2.
Okay.
All right. I know it goes quick. We do have to stop here though for
Okay.
tonight.